Hello ladies and gentlemen, welcome back to C.A.R. and I'm your host Dylan Hamilton, and today guys we're going to be continuing on with our A22 biology revision videos. We're on our way through inheritance here. We've done monohybrid inheritance and sex inheritance. We only have to do dihybrid inheritance, and then there's one more video after this and then we're done with inheritance. But yeah, dihybrid inheritance, that you'll definitely know it's 100% will come up in your exam. It's a guarantee essentially. You'll have to do a dihybrid cross. Easy marks when you know how to do them, so don't worry. It's just more or less, instead of having one characteristic, it's two characteristics essentially. So don't worry too much about it because we're going to go through it and you'll know everything there is to know about dihybrid crosses. So, an introduction. Well, dihybrid inheritance is the inheritance of two characteristics. So it's not just like your hair color or your height or something like that there. And even though your height's not really massively genetic anyway, because it can differ with your environment. But anyway, the gene will be found in different chromosomes. So these two genes will be unlinked that you're going to get the inheritance from. So dihybrid crosses, there's one right there for you. So for example, we'll use plants for an example. A plant can be tall and it can be round seeded. Okay, so these will be found in different genes, but you will be inheriting both. So in order to decide whether it be tall and round, or short and wrinkled, or tall and wrinkled, or round and short, we don't know. So we're going to have to try and figure that out. So a tall round seeded plant will be capital T, capital T, capital R, because if you're going to be tall, you're going to have a capital T, and if you're going to be round, you're going to have a capital R. So tall and round is capital T, capital R. Or you can have a capital T, a small t, and two capital R's, because obviously the dominant T will express itself over the recessive one. Or you could have two big T's and one big R, one small r, because obviously the dominant R will express over the small r. Or you can have a big T, big R, small r. Now if you want to be a short plant with a round seed, you're going to have two small t's, because it can't have a big T in order for it to be short. So it has to have two small t's, and it can either have two big R's or just one big R. And then if you want to be short and wrinkled, it's recessive everything. So two small t's and two small r's. So if we go to the cross here right now, the genotype we're going to cross is tall and round, capital T, capital R, and we're going to cross that with short and wrinkled, recessive, tall, two small t's and two small r's. So the gametes then, we cross that, so we get TR and TR. They're all big, and then for short and wrinkled, TR. The best way to do it is if you take the T on the far left, when we're looking at genotype here for tall and round, you go to the capital T, you cross that with the first capital T, you cross that with the first capital R, then you go to the second capital T, you cross that with do that with the second capital R, and there's no else really, there's no other combinations you can possibly do, and it's the same for short and wrinkled. So if we do, as you see here lined out, you have the two small t's in the top row and the two big R's, two big T and R's on the side rows. You cross the capital T with you cross big T, big R with small t, small r, you're going to get capital T, capital R, smaller, and that's going to be the same for all four. So the phenotype will mean it'll be all tall and round, and the genotype will be all capital T, big R, smaller. So this is where Mendel's second law comes into place, and this is the law of the independent assortment. And this is when, during the formation of gametes, the segregation of alleles of one gene will be independent to the segregation of the alleles of any other genes. So F1s then. So as we know from our previous cross, we obtained the genotype big T, big R, smaller. So what if we cross these two tall and round plants together? Let's see what their offspring would be. So obviously the gametes are different. There's more gametes. So we have capital T, capital R, capital T, small r, small t, big R, and then small t, small r. And the reason for that is if you go to the genotype here and you see the big T there, you cross that big T with the big R. You also cross that big T with the small r. Then you have that small t, you cross that with the big R, and the small t with the small r. And you do that for both. So it's going to be 4-4. So as we see here, lined out in the rows, as we see, if you cross the TR with TR in terms of big, then you're going to get all big. So you're going to get capital T, big R. And then if you cross that, etc., you're going to get all the way through until you've completed that table, and eventually you're going to end up with 9 tall and round, with the genotypes being 1 big T, big R. You're going to get 2 genotypes of big T, big R, small r. Then you're going to have 2 genotypes of big T, big R, and then you're going to have 4, which is 4 genotypes of big T, small r, big R, small r, and that adds up to 9 tall and round. So that's the that's the phenotype tall and round. You're going to get 3 tall and wrinkled, because you're going to get 2 genotypes of big T, smaller, smaller, and then you're going to get 1 genotype of big T, or smaller, smaller. You're also going to get 3 short and wrinkled because you're going to get 2 genotypes of 2 small t's and 2 big R's, and you're going to get 1 2 small t's, 1 big R, 1 smaller, and then finally 1 short and wrinkled, which is 2 small t's and 2 small r's. So the phenotypes are going to be in the ratio of 9 to 3 to 3 to 1, which is expected with unlinked genes in a dihybrid cross. So the heterozygote and the double homozygous recessive then. Well, we will usually obtain a 1-1 when you cross a double heterozygote with a double homozygous recessive. So as we see here from the front, we have a double homozygous recessive and the 2 small, with the 2 small there in the TR, and we cross that with all the gametes at the top. So, and then you're going to get 1 of each. None of those overlap. They're all completely different. So it's 1-1. So the genotypes are done by crossing big T, small t, big R, smaller, and you times that by the recessive. So as we see, double heterozygous, because obviously you have a big T and a small t, that's heterozygous, and then big R, smaller, that's heterozygous. So, and you cross that then with your double homozygous recessive, which is 2 small t's, 2 small r's. So the gametes, as we see, are there, and the genotypes, which is what we get, and we're going to get 1 tall and round, 1 tall and wrinkled, 1 short and round, and 1 short and wrinkled, and this is known as back crossing or test crossing, and this is always done with your homozygous recessive. Thanks for watching this video. I've been Dylan Hamilton from C.A.R Entertainment, and I'll see you next time.